Greetings, math fans. All right, so this is the homework for the first day of related rates. All right, so let's get started here. First we'll start with number 1. And let me just read the question here real quickly. It says the radius r and area A of a circle are related by the equation area equals pi r squared. And they simply want, and it says write an equation that relates dA dt to dr dt. So basically you're taking the derivative of both sides, which is really easy. And so you're going to do dA dt is equal to pi, the derivative of r squared is 2r, and then dr dt. Okay, and then of course just going to kind of simplify it here a little bit. dA dt is equal to 2 pi r dr dt. Okay, so just kind of an interesting thing here too, area and circumference. All right, number 8, we got to fit a couple problems here. Number 8 says, when a circular plate of metal is heated in an oven, its radius increases at a rate of 0.01 centimeters per second. At what rate is the plate's area increasing when the radius is 50 centimeters? All right, so again, we're talking about the area, right? And area equals pi r squared. And they're telling you the radius is increasing at a rate, so they're giving you dr dt, and that's 0.01 centimeters per second. And they're giving you, they want to find when the radius is 50 centimeters, so r is equal to 50 centimeters. And the question they're asking you is find basically dA dt, right? Find the rate that the plate's area is increasing. So again, you don't plug this into that now. You have to take the derivative first, because if you plug it in at that point, you're just going to get the area, but not when it's changing, as it's changing. And that's what you need to do. We need to find dA dt. So that's really easy. I'm taking the derivative, so dA dt is equal to 2 pi r, same thing as before, 2 pi r dr dt. And now we plug it in. dA dt equals 2 pi times 50 times 0.01. And that gives us basically the 2 and the 50 and the 0.01 all cancel out, and we just get pi centimeters squared per second. Right? Because they're asking you at what rate is the area increasing. That's why it's square centimeters per second. Okay, so that's our answer. All right, number 9, a little bit longer, so let's delete this guy here. And it says, changing dimensions in a rectangle. The length L of a rectangle is decreasing at a rate of 2 centimeters per second, while the width is increasing at a rate of 2 centimeters per second. When length is 12 centimeters and the width is 5 centimeters, find the rate of change, and they give you a bunch of different things here. So let's write out, this is number 9, let's write out a couple things here. First of all, dL dt, change in length, is decreasing by 2 centimeters per second. And dW dt, the width is increasing by 2 centimeters per second. And they give you that the length is 12 centimeters and the width is 5 centimeters. Okay, and A tells you find dA dt. So really, our area formula for rectangle, of course, is area is equal to length times width. And then we're going to take the derivative. Okay, and of course we're going to use, in this case here, the product rule. And well, first of all, it's dA dt. So it's the first times derivative of the second, which is derivative of w is just 1, of course, then it's dw dt, right? Plus the second times the derivative of the first, so dl dt. Okay, so let's plug everything in here, and we have 12 centimeters is the length, and dw dt is 2 centimeters per second, and then plus 5, which is the width, times dl dt, which is negative 2. So my answer to this one is 14 centimeters squared per second. Okay? B, it says find dp dt. So I'm looking for the change in perimeter. And so we'll just write our little equation here. Perimeter is equal to 2L plus 2W. So we take the derivative. So we have dp dt is equal to, and don't do product rule here. I mean, just think logically. It's 2 times then the derivative of L. So it's just 2 dl dt plus 2 dw dt. Okay, so that's equal to 2 times negative 2 plus 2 times positive 2, which is equal to 0. So the answer is 0 centimeters per second. So what does that mean? It means that the perimeter is not changing. Okay? It's pretty much what it is. Okay? And it's just kind of interesting, right? It's saying that the length is decreasing and the width is increasing at the same amount. So of course the perimeter is not going to change. All right? C, they ask for find the rate of change of the length of the diagonal of the rectangle. So let's just kind of make a quick sketch here. And we're going to call that's the length of the diagonal, and here's your length and here's your width. Okay, so D, if I want to relate all that together, because I need to, I have D is equal to, using the distance formula, right? Or Pythagorean theorem, however you want to look at it, L squared plus W squared, the square root of that. So it just makes it easier when I write it this way. Easier to take the derivative of, right? So we have d dt is equal to, of course we're just going to use the chain rule, so you get 1/2 L squared plus W squared to the negative 1/2 power times, and then the derivative of the inside, which is 2L dl dt plus 2W dw dt. All right, and let's move this down here a little bit. d dt. You can kind of simplify this a little bit and put this basically this L squared plus W squared to the negative 1/2, that just goes to the bottom. So I really have, well, I'll just write it out here. 2L dl dt plus 2W dw dt. And I could simplify this if I wanted, but we're just plugging it all in, so it really doesn't matter. And that's L squared plus W squared, and that's to the 1/2 power. Okay, didn't even need to do that, right? Because I'm plugging it all in my calculator. But my numbers here are 2 times L, which is 2, dl dt, negative 2, and then plus 2 times 5 times positive 2, and that's all over 2 times L squared, which is 12 squared plus 5 squared to the 1/2 power. Okay, which of course is, it's just a 5, 12, 13 triangle. We know that. So, but we can, dd dt is equal to negative 48 plus 20 on top over 2 times the square root of 169, which is negative 28 over 2 times 13. Just kind of showing a little bit of work here, which is negative 28 over 26, which finally reduces to negative 14/13 centimeters per second. So that's what the diagonal is changing. Okay, so the diagonal is decreasing as the values of L and W change. All right, and the last part of that question is part D, and it says, it's a right to learn question. It says, which of these quantities are decreasing and which are increasing? Well, that's just pretty easy. Basically, let me just write this out here. The area is going to increase, so area increases until it forms a square. Right? That's actually maximum area, a square. As soon as you start stretching that square, becoming a rectangle, the area actually decreases. So in this case here, again, dA dt is greater than 0. Okay, so it's increasing until it gets to a square. The perimeter will always be the same. Is always the same. Because the length is decreasing and the width is increasing, okay, by the same amount. Okay, so that's why dp dt equals 0, no change. And the diagonal will decrease, and that's the same thing. It'll decrease until it forms a square. Okay, because again, that's your most, that's the smallest value, right? With a square. As soon as you start making it into a rectangle, that diagonal will increase. So in this case here, it's turning towards a square. So dt is going to be less than 0 because it's shrinking. Okay, so that was kind of a long problem, but that's number 9. All right, let's move on to number 13. It's very exciting. All right, air traffic control. An airplane is flying at an altitude of 7 miles and passes directly over a radar antenna as shown in the figure. Okay, you guys should have your book out anyway, looking at this. When a plane is 10 miles from the antenna, that's your value of S, the radar detects that the distance S is changing at a rate of 300 miles per hour. Okay, it's a rate of change, miles per hour. What is the speed of the airplane at that moment? The speed of the airplane, so if I look at the picture that's drawn, math fans, this is what you have. Okay, and they tell you in this case, well, so this is Y, this is X, and this is S. Okay, and then Y is equal to 7 miles, and S is equal to 10. This is when the plane is 10 miles from the antenna, so S equals 10 miles. Okay, and then your rate of change, which is ds dt, is equal to 300 miles per hour. Okay, and that's the rate of change, distance per time. Okay, ds dt, change in position over change in time. Okay, and so then what they do is what I'm looking for is I'm looking for the speed of the plane. That's actually dx dt, isn't it, or the change in speed of the plane? Okay, because the plane is flying horizontally, and that's why it's dx dt. All right. First of all, I need to relate these guys together. So x squared plus y squared equals s squared. And the first thing I want to do is I need to actually find the value of x. If I'm going to take the derivative, I need to find the value of x. Well, that's pretty easy because I can just plug that into the equation, right? It's just Pythagorean theorem. And so it's going to be x squared plus y squared, 7 squared, equals 10 squared. So x squared equals 100 minus 49, or 51. So x equals square root of 51. Okay? And now I want to take the derivative with respect to time. Okay, that just gives me that value of x. So again, I'm going to go back to, I got x squared plus y squared equals s squared. Take the derivative, I get 2x dx dt plus 2y dy dt equals 2s ds dt. Very exciting. All right. Now, this is the deal. That plane is the x, right? It's flying horizontally. The only thing that we, first of all, we're looking for dx dt. So let me just write this down, dx dt. We have x, y, and s. We have ds dt. The only thing we don't have is dy dt. How do you figure out dy dt? Well, actually, dy dt is 0, right? Because it's not changing its altitude at all. So that's a constant. So dy dt equals 0. Okay, so then we have 2 times x, which is square root of 51, dx dt, plus 2 times y, which is 7, times dy dt, which is 0, equals 2 times s, which is 10, times ds dt, which is 300. All right, and obviously that goes away, and I divide both sides by 2 root 51, and I get dx dt is equal to 6,000 over 2 root 51, which is 3,000 over the square root of 51. And just in general, as an application problem, unless it says give an exact answer, it wants an answer in terms of numbers, right? You're going to the board of directors. They're not going to, if you tell them, oh yeah, the plane is changing, its speed is changing by 3,000 over root 51, they're going to be like, really, what planet are you from? Okay, they want to know some numbers here. So it turns out dx dt, you divide that out, you get 420.08 miles per hour. Okay, that's the answer to that one. So that's just recognizing that this guy right here, math fans, is the dy dt is 0. Okay, so you got to kind of watch that. All right, let's do the next one here. This is number 14. It says, flying a kite. Inga, good old Inga. Inga flies a kite at a height of 300 feet. The wind carries the kite horizontally away at a rate of 25 feet per second. How fast must she let out the string when the kite is 500 feet away, or 500 feet away from her? All right, so let's just draw a picture here, just to explain what's going on. It's a right angle, and this is going to be 300 feet. Okay, because the kite is a height of 300 feet, and you want to know when z is equal to 500 feet. Okay, because it says how fast must she let out the string. Okay, so what are we looking for? We're looking for dz dt, right? That's how fast she's letting that string out. So that z over time. Okay, change in z over change in time. All right, and it says the wind is carrying the kite horizontally at the rate of 25 feet per second. Okay, so if I call this x and this is y up here, dx dt is 25 feet per second. Okay? So we have everything. The only thing we don't have is we don't have x. Okay, well, of course, we have enough information to find x because we know z is 500 feet and y is 300 feet. We know this is a 3, 4, 5 triangle. So we just know that x equals 400 feet. Okay, or you could use Pythagorean theorem, either one. Okay, so let's relate our variables. X squared plus y squared equals z squared. And let's take the derivative with respect to time. So we get 2x dx dt plus 2y dy dt equals 2z dz dt. All right, and what's another thing we notice again is that kite really getting any higher? If I look at the problem, it's flying horizontally at a rate of 25 feet per second, and it says the kite has got to be at a height of 300 feet. So that's not changing. So that's why you know dy dt equals 0. Okay, another important thing, right? So let's plug all that stuff in there. We get 2 times 400 times 25 plus 2 times 300 times 0 equals 2 times 500 dz dt. Okay, that's out of there. And because it's a constant height, and we get 1000 dz dt is equal to 20,000. So divide dz dt is equal to 20 feet per second. Okay? Not too bad. Not bad, not bad. All right, let's go on to number 19 here. And 19 says it's a sliding ladder. So let me clear this out here. And again, you got your picture in front of you. A 13-foot ladder is leaning against a house. See the figure. When its base starts to slide away, by the time the base is 12 feet from the house, the base is moving at a rate of 5 feet per second. So there you go. We have a rate. So it's that's something with respect to time. And then they got a bunch of questions here. So let's make a quick sketch. And we have an angle actually involved in this one here. So let's put that on there. And let's see, the ladder is 13 feet. So this is 13. And it's saying that the base is moving at a rate of 5 feet per second. Okay, so we're going to, if this is x, dx dt, the base is moving at 5 meters per second, or 5 feet per second. Okay, and so it says by the time the base is 12 feet, so actually x is equal to 12 feet. Okay, that's all you're given, and then we're going to call this y. Well, again, we can figure out y pretty easily, right? It's just a 5, 12, 13 triangle, or Pythagorean theorem. So y is equal to 5 feet. That's pretty easy. And what we're doing is we're looking for dy dt, right? Because the question is, how fast is the top of the ladder sliding down the wall? So they want to know the vertical change. So we're looking for dy dt. And there's 3 parts to this. So this is part A, dy dt. And so let's set up our nice little equation here. You guys agree it's x squared plus y squared equals, and we'll just call that z squared. So we take the derivative with respect to time. So we get 2x dx dt plus 2y dy dt, or dy dt equals 2z dz dt. Okay, what's constant here? Well, didn't you just agree the ladder, it's never changing height, right? It's staying at a 13-foot ladder. So that's why you can say dz dt equals 0. Okay, so let's plug it in. We have 2 times 12 and times 5 dx dt plus 2 times y, which is 5, dy dt equals 2 times z, which is 13, times 0. Okay, so we basically get 10 dy dt is equal to negative 120. So dy dt is equal to negative 12, and that's feet per second. Now, you could give it as that an answer, or you can say down, it's sliding down at a positive 12 feet per second. So either way is acceptable, right? Okay, so let's look at B now. B says, at what rate is the area of the triangle formed by the ladder, wall, and ground changing at that moment? Okay, so that's kind of a good, interesting question. At what rate is the area of the triangle formed by the ladder, ground, or wall and ground changing at that moment? So I'll do everything up here so we can kind of keep all the information here. Do you guys agree this is just area of a triangle? Area equals 1/2 base times height, which is really 1/2 x times y, right? So if I take the derivative of that, dA dt, there's that derivative again, change in area with respect to time. We're going to use the product rule. So it's I'll just put the 1/2 outside here, and then it's the first times the derivative of the second plus the second times the derivative of the first. Okay, so that's equal to 1/2. X is 12. dy dt is -12. Plus y is 5. And dx dt is 5. So that gives us 1/2 times -119. So we get, kind of getting kind of messy here a little bit, but dA dt is equal to -59.5 square feet per second. Okay, not too bad. Okay, and then for number 19C, it says at what rate is the angle theta between the ladder and the ground changing at that moment? So that's why I put the theta in there, math fans, is we're really looking for here d theta dt. So we can just use a little right triangle trig, right? Because this is, of course, is right triangle. And I'm going to use, you can either use sine or cosine. One you're going to have an x and one you're going to have a y. All right, but we have that 13, the hypotenuse, which is constant. So it's going to be, I'm going to use sine of theta is equal to y over 13. Okay, and then I take the derivative of that. I get the derivative of sine is, of course, cosine of theta. Of course, then d theta dt. And then it's a lot easier to look at it as 1/13 y, which will just give you 1/13 dy dt. Okay, and then if I plug everything in, cosine of theta is just going to be 12 over 13. It's our nice ratio. 12 over 13 d theta dt. I'm going to run kind of out of room here, but that's okay. 1/13 times dy dt, which is -12. And then here I'll make a little more room now. So I'm going to bring it down to here, okay? And then I have d theta dt is equal to 1/13 times -12 times 13 over 12. Just multiply by the reciprocal, and you wind up getting d theta dt equals -1. Now again, always an application problem. We're talking about, like remember we talked about science and engineering, it's going to be in radians. So that's what your answer, it's -1 radian per second. And that's the answer to that. Okay? Not too bad. Okay, so let's take a look at number 20. It's our last one. It's a filling a trough problem. Very exciting. A trough is 15 feet long and 4 feet across on the top as shown in the figure. You've got to take a look at the figure. It's really, really important to look at that figure. Its ends are isosceles triangles with height of 3 feet. Water runs into the trough at a rate of 2.5 cubic feet per minute. How fast is the water level rising when it is 2 feet deep? It kind of looks a little complicated, but it's actually really not that bad. So let's write a couple things down here. First of all, let's draw a picture. So this is number 20. And this is really what I have. I'm going to draw like an end view of the trough. Okay, so one is 4 feet. And we're going to call this our second base because we don't know what that is, right? When because it tells you a trough is 4 feet across on the top, but when it's 2 feet deep, So it kind of changes a little bit. All right. Anyway, so this distance here is 3. That's the hardest part. One of the hardest parts is maybe drawing a picture. And then this distance to here is your height. Okay, so they give you a few things. First of all, they tell you the height is 2 feet. Okay, they tell you the change in volume. So the volume is, or it's running into the trough at a rate of 2.5 cubic feet per minute. Okay, and they're asking you to find dH dt. Okay, how fast is the water level rising? How fast is H rising when it's 2 feet deep? So what I need to do here, math fans, is I need to find the relationship between H and B. And the way we're going to do this is you need to understand that I really have similar triangles. So let me just draw this real quickly. Right? This one is 3. That's the height of that. And this is 4. And then this guy here is H and B. These are similar triangles. All right? And because they have the same angles, right? The water level is the same. I mean, it forms the same angle for B or for 4. That's why they're similar triangles. Okay? And so what I can do is I can say then 3/4 for the big triangle is equal to H over B. So I got 3B, cross multiply, 3B equals 4H. And I get B is equal to 4/3 H. And our volume of this figure is 1/2 base times height times the length. Okay, it's not like it's a difficult problem as far as even that formula, right? It's basically, if you guys remember from geometry, it's the base area times the distance between the bases. The area of a triangle is 1/2 base times height. The distance between the bases is 15 feet, which actually is given as well. So let me write that. L equals 15 feet. Okay? That's why I need to, again, I'm looking for dH dt, and I don't want to be in there because I don't know dB dt, right? I have no idea, so I can't keep that in there. I actually have to solve, in this case here, I solve for B, so I can just have it in terms of H. So let me plug that in. V equals 1/2 times 4/3 H times H times L. Okay? And L is going to be constant. Do you guys agree with that? So I can actually kind of just put that right in there, and I don't have to worry about it. So L is equal to, if I multiply all this out, I get 2/3 times H squared, and L is actually 15 feet. Okay, because again, that does not change at all. L does not change. And all right, so let's keep going here. Let me just simplify it. V is equal to, that's going to be 10H squared. Actually turns out to be a really easy problem, right? And then I do derivative, dV dt is equal to 20H dH dt. And then I can plug everything in. So I get 2.5 is equal to 20 times 2 dH dt. So I divide and I get dH dt is equal to 1/16 feet per minute. That's how much the height is changing. Okay, so before I end this actually, math fans, I want to point out one thing here. First of all, this L, I plugged in 15 feet, and some of you are saying, well, why did you plug in a value right away? Well, if I wouldn't have plugged in let's say I would have kept it as L, which is okay. If I would have taken the derivative, it would have been the product rule. Do you guys agree with that? So it would have been, let me highlight this in red, it would have been this guy times L. So think about it. If I would have, we know dl dt is equal to 0. So if I would have said the first times derivative of the second, they would have canceled out, right? Do you guys agree with that? Plus the second, which is L, times derivative of the first, which is 15 feet times derivative of the first, which is actually what I did here. That's what that is, right? Because 15 times 2/3 h cubed is 4/3 h times 15, which is 20h. Okay, so you didn't. I just wanted to show you both ways to do that. I mean, I plugged it in because L is a constant there. It doesn't change, so that's why when the product rule would have occurred, dl dt would have been 0, and that would have canceled out. But I get the same answer. Okay. Anyway, that's it. It's just make sure you are drawing good pictures, and and probably labeling variables, writing out what each variable is. If you see something like miles per hour or whatever, that's your change in position over change in time, or change in volume over change in time. Make sure you write all that out. It's really important, and come up with all your formulas, relate your variables, and simplify. All right, and then also remember constants, right? Something's flying straight across, that means its height is constant, so h dt would be 0. So just kind of watch some of those things. All right, that's it, math fans. Have an outstanding day. Adios. Goodbye.